This video in the Pure Maths 1 course concerns the sigma notation, which is used for summation of series. This is an arithmetic series, 2 plus 4 plus 6 plus 8 and so on until we add 20, and it's an arithmetic series with 10 terms with common difference 2, starting with first term 2. Now, another way of writing this is like this. Sigma, and that is this symbol here, which is the Greek letter S, and it's the uppercase. And then we can write from 2r here, so that's meaning 2 times a number, where r is the numbers starting with 1, so 2 times 1 is 2, then r is 2, 2 times 2 is 4, then r is 3, which gives you 6, when r is 4 gives you 8, and you need r up to 10 till you get 20, so r must be 1 until r is 10. So that whole notation, r equals 1 to 10, that means r takes all those values 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and you substitute those values into the expression 2r, which gives you 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20, and you add them up, and so we end up with the series that I have above, like that. As I said, this is the Greek letter sigma, and it's the uppercase. The lowercase sigma is this a symbol like that, and that's the lowercase sigma. Sometimes we don't write the r equals, we slightly shorten the notation. It could be r equals 1 to 10 without r equals 10 at the top, or it could be just 1 to 10 like that without r equals. The r equals is implied. Also, we could have a symbolic r equals 1 to n of 2r, so it would mean that the r, we substitute the r into the expression, and then we end with n, so that would mean 2 plus 4 plus 6 plus until you get to 2n when r is n. So some examples. First one, evaluate sigma from 1 to 10 3r plus 2. So let's start by substituting values into this expression. We start with r equals 1, so that would be 3 plus 2, which is 5. r is 2, that's 5 plus 2, which is 7. r is 3, that would be 9 plus 2, which is 11. And we continue until r is 10, which will be 30 plus 2, which is 32. We see we have an arithmetic series. The first term is 5, common difference is 2. Okay, made a mistake here. Of course, it should be the second term, r is 2, 3 times 2 is 6, plus 2 is 8. So correct that. And d is 3, of course. And we can see that 3 from the 3 and the 3r, in fact. We have 10 terms. r is 1 to 10. Here is the n. And so that's an arithmetic expression. S equals n over 2, 2a plus n minus 1d, an arithmetic series I should say. So substituting, n equals 10 over 2, 2 times 5 plus 10 minus 1, 9 times d, which is 3, and that comes to 185. Second example, here we have one where it doesn't, the terms don't start with r equals 1, we have r equals 4, we don't need to start r equals 1. So if we start writing down these terms, we'll have 7 minus 4 over 4 plus 7 minus 5 over 4 plus 7 minus 6 over 4 up until 7 minus 11 over 4. Simplifying gives us this series here, and if we want to evaluate the sum, again we have a equals 6, d would be minus a quarter. We're taking a quarter from each term, and we have, well, between 4 and 11. Now here you have to be a little bit careful. How many between 4 and 11? You could subtract 11 minus 4, so take 4 from 11 and you'll get 7. Now that won't be correct. What you should think of is, well, if I had 1 to 11, that would be 11 terms. But I start at 4, so I don't have 1, 2 and 3. So that's only 3 terms missing. So we should say 11 minus 3 is 8. N equals 8. So S equals 8 over 2, 2 times A, 2 times 6, plus n minus 1, which is 7 times minus a quarter. And that equals 41. For the third example, here we have a series. Now supposing we want to use the sigma notation to write this series. Well, if we notice that when we were using the sigma notation in the other examples, the expression we have, 7 minus r over 4, is the nth term. So let's find the nth term. The nth term, or un, would be, in this case, well, the first term is 5 plus n minus 1d. Well, we don't know n, so it's n minus 1 times d, and the difference is 4. And the nth term we know is 37. So that gives us 5 plus 4n minus 4 equals 37. 4n plus 1 is 37. 4n therefore is 36. N equals 9. What we need to know is, what is UR, the rth term? And that would be a plus r minus 1d. In this case that is 5 plus d is 4, so it's 4 r minus 1, which will come to 4r plus 1. So UR is 4r plus 1. So the expression would be sigma 4r plus 1. R, we start at 1, and that means when r is 1 we have 5, and we have 9 terms, so that n is 9, so we end with r equals 9. And we see if we put r as 9 we get 37, which is what we have. We start at 5, we end at 37. Now please return to Study Smart, where you'll be able to download some exercises and you'll be able to practice.